Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the last episode in the Coding a 2D Game Engine series. So in this episode, what I'm going to be talking about is just some bug fixes that I went through. I will talk about things you should refactor and future improvements to the engine that you should consider trying yourself. So we'll sort of wrap this series up with a nice bow, and hopefully you guys will be happy with where we've ended. So I've ended this just by building out the first level in Mario, which we can sort of see in a minute. And so you'll see that I have fixed up most of those bugs that were sort of lingering, and everything sort of works good. You can play this like you would the Mario game, and it just works, which is really cool. And not only can you play this like you would the regular Mario game, but you can also go ahead and build any game you want, right? The platform we've built is particularly suited for 2D platformers like this. However, you can build any sort of thing that you like. It doesn't have to be a game like this. And you have the base here to do that. Like, everything here should work, and you can sort of extend this engine just to support those different things. And so I'm really happy with the way this has turned out. You'll see that at the end there, I forgot to change the Z indexing of those pieces of the castle. But yeah, so first of all, let me go through the bug fixes that I have made, and we'll talk a little bit more about some of the features I've added, such as these coins, and then I'll talk about some of these things that you could do yourself. All right, so I am at the repository for this game, which you can find in a link in the description. I'm just at the master branch on the latest commit. And so we will sort of look through this, and I'll talk about some of the changes I've made. Now, the very first change I've made is I've updated Gradle to build an output jar. This is something you might want to do if you want to add a way to distribute your game, right? Most of us want to be able to build our jar and just distribute the game. And so I've added a method for doing that. You'll notice that if I go down into our project file now, and if we open up the command prompt, you can go ahead and run Gradle tasks. And what this is going to do is it's going to list all the tasks that are available in our Gradle build file. So we'll take a look at how this all wraps together. But basically, we have these build tasks, which are assemble, build dependencies, and then there's one specific task that I've added, which you can find when you run Gradle tasks -- all. And so if you look under these other tasks, these are the tasks that we've added. So we have compile Java, compile test Java, and then fat jar. And this fat jar in particular is the one that I want. So if we run Gradle fat jar, then this should run that task. And what's going to end up happening is it's going to build us a jar. And it's called a fat jar because it contains all of our dependencies. So then if we look inside of our build directory, inside of the libs folder, we get this Mario snapshot -all.jar. And so if we just open up a command prompt in here and we run Java -jar Mario all.jar, this goes ahead and runs our game, which is not running correctly at the moment, simply because we're missing our level.txt file. So this is part of the distribution process. If you want to make sure that nothing is going to break, then you could copy this txt file. We'll paste it into here. That way we have that loaded at runtime. And now you'll see that we get another exception because we're missing our assets folder. So this is stuff that you would want to do before you distribute. So I could copy those assets, copy this into our libs directory as well. And now when we run this, we should get a successful running of our game. And you'll notice that it's sort of moved all of our windows all over the place just because we don't have our IamGUI init file in there. But this is our game, and this is it running just from a jar, which is pretty cool. And I know that's what a lot of you have asked about. How can you distribute something like this? So now you basically have whatever you have created, and I'll just dock this as well. You have whatever you've created just wrapped up in this jar with those assets. And so if you wanted to distribute this now, we should be good here. You could just zip up all of these folders and files, and then you could give it to your friend. And as long as they have Java installed, they should be able to even just double click this and it will run the game. So this is how you would go about distributing. You can get into more advanced things. Say you want your friend to be able to play this without having Java installed. Well, you can package the JVM, so the Java virtual machine for your specific Java game, within an executable, but that gets a little bit more complicated, and there are some methods of doing so. How do you get this fat jar though? Because the reason we need the fat jar is because we have a lot of extra dependencies, which you can sort of see inside of our libs directory. We have this jbox2d library.jar, but we also have a lot more dependencies that are pulled in using Gradle. And so the way I found it, I'm not very familiar with Gradle, but I found something on Stack Overflow that gives a quite easy way to wrap everything up into a fat jar. So you basically have a build dependency or a build task called jar, which creates a jar and gives the class path and basically gets all of our classes wrapped up. And then you just define what your main class is. So this is the class that has your main function in it. And then you can just collect all of your different dependencies using this from clause, from the way I understand it. And then to get the fat jar, you basically just run that build task, which is jar. So we say with jar. And then we also add in that we want to get all the dependencies and we collect all of the runtime dependencies as well. And then we exclude anything that we don't need. So like I said, I'm not familiar with Gradle that much. And then we can finally add it as an artifact here to make sure that we can actually build an output. But this should basically do the job for you no matter what. And as long as you have all your dependencies inside this build.gradle file, like we do here, where if you actually look into the Gradle file, you can see that we have all of our dependencies defined here. Then it should collect all of these DLLs, whatever you need, and it will package them all together for you automatically. So that's how you could go about distributing. Now let's take a look at the next commit I have, which was fixing the Mario collisions as much as possible. And we're going to talk a little bit more about this too afterwards. So you'll see that the main changes I have, you can ignore the level.txt changes, but I removed this import, which was not needed. And then inside of player controller, I've changed up the pillbox collider a little bit. So that's why I have it setting it to a different height. And inside of prefabs, I also changed up just the width and the height to work with the new pillbox collider. And then inside of physics 2D, I simply removed this line from our pillbox collider because I changed the way it works right now. You may have noticed that when I was showing everything, because now it's just a circle and a box. And then so circle collider, I just added a few different features, which are directly from the pillbox colliders. There's nothing really special in here. You can take a deeper look if you like. And then inside of the pillbox collider is where the real big changes happen. So basically, I've just changed the way I calculate the dimensions for the pillbox so that we get a better fitting pillbox. And then very specifically here, I make sure to set the box's half size to the width of the pillbox minus 0.01 to try and avoid catching on edges. However, this does not fix all of the catching on edges problems. So if we go back to that fat jar we just created, and we can actually see this. So the best way to sort of demonstrate the problem I'm talking about is if I just go up to an object like this. There we go. That did it perfectly. So Mario catches on the edge of this, and I've debugged this quite a bit. And this isn't anything to do with like our physics. It's not anything to do with the way the box colliders are set up. It's just the way that Box2D works. I will have this linked in the description, but we can get, there's a good article here that actually talks about these specific problems. And so you can see that this is another one sort of demonstrating this problem where your character gets caught on edges. And the reason it does this is because Box2D doesn't work very well with tile grids and box colliders set up right next to each other and everything. So the way you can fix this, basically what this article ends up showing is using edges instead of shapes. And so I'm not going to go over how to do this because I don't want to invest the time to do this, but you definitely should if you want to use this for your game. Basically what you can do is you can create edges that wrap around whatever your blocks are. So in our case, in order to get this to work properly, we have a bunch of box colliders around each of these cubes. What you would do instead is create some sort of algorithm that looks around here. And then for all of these colliders, instead of having box colliders for each one, you would basically, let's move this over here too. You would basically create an edge collider that just goes around the top of this. One big edge collider, then it goes up here, then here and here. And so you'd basically build that edge collider at runtime using all the information of these static blocks and everything, and do something along those lines. That way Mario doesn't get caught on the edges and you have better performance too, since you have much less physics bodies. So that's sort of the basic approach, and you can take a look at this article for more information. I will link it in the description. Okay, on to the next commit, which was fixing Mario passing through enemies when hurt. So when Mario gets hurt, he should pass through enemies. He didn't before. The way to fix this was we just need to switch begin collision to pre-solve, because you can only disable contacts in the pre-solve method. And so then we need to simply check and see if player is not dead yet. If he's not dead, then we're going to disable the contact. And then we're also going to have to do this every frame we're touching the player. So if the player controller is not dead and he's invincible right now for whatever reason, then we're going to disable the contact so he doesn't collide with enemies. So this should make it so that he's not hitting enemies when he's hurt. And then I did the same thing for the mushroom. I basically say if the mushroom's not colliding with the ground, disable the contact so that he doesn't collide with anything. And then you'll see that I also adjusted the pillbox collider for Mario, just another adjustment. And then I did the same thing for the Goomba AI. I basically checked to see if the Goomba is colliding with something and it doesn't need to be. We disable the contact if we can. Same thing here. We also do the same thing here. And finally, I do it with the turtle AI in the next video, which we'll see in a minute in the next commit. And then I also reset Mario's Z index to 10 just so that he's in front of the whole world. So next one I fixed was fixing turtle with the Mario fireball bug. So basically, when a fireball hit an enemy, the turtle wouldn't spin as fast. And this was actually a really simple fix. This acceleration.x really isn't necessary, but all I had to do was do walk speed times 3 if the turtle dies from a fireball. That was all I was missing. And then that should make it so that the fireball actually makes the shell spin fast. I also added in this clause, which basically makes it so that the fireball can stop and start shells moving, and it can change the direction of everything, and fireballs do not collide with the turtle shell. Okay, and then I added coins to the game. So now we have coins added to the game that you can actually collect, which I'll show in a minute. But basically, these are very simple. This is basically taken directly from block coin with the added addition of this play animation. And basically we just say if the player collides with us, we disable the contact and we play the animation and we play the coin sound. So very simple. And then I added a prefab generator method for that coin and added a button to create that coin. And finally, we fixed the rest of the bugs except for Mary Poppins Goombas, which we will see in a minute. So basically right here, I say if the Goomba is to the left of the screen, we destroy it so that it's gone now. We're not updating that. If the player controller is small, we power up if we hit the mushroom. But if he's already big, we just play a sound because we don't want to power the player up again if he's already big. And then this was a fix for the pipes. You couldn't enter in pipes. I had some debugging stuff in here still. But basically, you could not enter pipes if they were left or right, so I just switched up the arguments here, and that fixed that. And finally, the turtle AI, we basically check to see if it's colliding with the mushroom. And if it is not colliding with the mushroom, just to avoid collisions with the mushroom in this case as well. So that wraps up pretty much all the changes I made. If we take a look at the game one more time, I can sort of highlight some of those changes a little bit more. So first of all, I added coins to the game. So you can now add in coins just by dragging a few in. And then if Mario runs through them, he collects them. So that was basically that addition. And you could see it uses the same animation and everything that we just saw there. But yeah, this is basically it. There's a lot of bugs in this game. So let's go through some of the bugs I would suggest fixing now. So one of the things, our gizmos don't really work. You can hover over them, but you can't drag things anymore. I would suggest fixing that because it's nice to have that and maybe adding some extra editor support for that. Another bug that we never really fixed is if Mario falls down, he doesn't really die, which I just never added that functionality in, but you could add that in pretty easily. So if you fall down here, he actually just falls down to the lower level, you'll see, and we're actually ending up in another room. That shouldn't happen. He should actually die. And then the same thing happens if you fall through in a different area. You'll just keep falling forever. So that's another bug I would fix. There are lots of things that I would say you should refactor as well. The code is not the best. There are many different things that you could fix, and I encourage you to do so. This was not intended to be how to write perfect code. This was intended to be a tutorial showing you how to get stuff done. One particular bug or refactoring that I would consider doing is inside of our scene, the level editor scene initializer, we have a very big block of code if you've been following this, where basically we do exactly the same thing many different times, and that can be abstracted to a function. This particular stuff, I would highly recommend creating some sort of function callback that basically just calls this function that you want, because everything else is the same. So you could create a function to abstract all of this logic, reduce a lot of those lines of code. Another thing I would consider doing is adding a actual prefab inside the engine itself. So the ability to create a game object and then make that a prefab that you can drag in. Right now, we're just doing all this in code. It's very laborious. It would be much better if you could do this all throughout the engine itself. Another thing that we don't have, but which would be nice and isn't too hard to add in, is the ability to remove components. So right now, you can't really remove any of these components, but you could add a delete button at the bottom of each of these pretty easily that just removes the component you're currently on, and that way you can add and remove components. Well, that's another thing. We can add rigid body, box collider, and circle collider, but we have no way to add any component. So another feature you could add is adding any component using reflection to find out the different components. Another thing I've had some people ask me is, how do I separate the engine from the code? Well, the engine is mainly separated from the game code. If we take a look at this, you can see that we've clearly segregated all of our game code so that it doesn't interact with the engine too much. So all of our game logic lives in this components folder. If you want to make a new game, remove all the Mario components from here. If you want to make your engine more extensible and make this into a library, remove all the Mario components from here, and then create a way to load new components in at runtime. And then we added some Mario code inside of our scene, the level editor scene initializer as well. So you could add in a way, if you want to make this a library, where you call a function that the users can initialize whatever assets they want to. They can also initialize whatever sprite sheets they want to, add whatever sounds they want to, and you basically just call a function for them. Or maybe they inherit from a class that has a function they can override. It's as simple as that. And then they can add in their own user code for that specific game, and you can reuse the rest of the engine as you see fit. Because most of our engine is separated, which is really good. The renderer is agnostic to the game. It doesn't care about what you're doing in the game. All of our utilities are agnostic to the game. They just deal with basic components. Our editor itself is agnostic to the game. It doesn't care what game you're playing. Our observers, they're agnostic to the game. So all of this stuff is separated already. The game logic lives in this components folder, and it lives in the level editor scene initializer. So if you want to challenge yourself, refactor those components out, transform this jar into a library for your engine, and then inherit from a class that allows you to get custom runtime components and custom initialization logic. And now you have an engine that is separate from your game code, and you can reuse it. So it's a very fun project. I encourage you to try it out, and you'll see that it's really not that bad. So that is basically it for this series. Now I'm going to play a fast forward version of me creating the first level of Mario, and just sort of talk through some of the things that I've heard from several different people. Now, I have had a lot of people saying that the code is not the best. I agree, it's not. That's why I encourage you to make it better. The thing I wanted to show you guys mostly in this code is that you can get stuff done. We have a working game, and it works quite well. Another thing that you may not be happy with is the performance of this. Now, this is already performing way better than if you were to use like a CPU-based graphics library, but we didn't really rely too much on any sort of optimization techniques. If you want to increase the performance, I would highly recommend finding a free profiler for Java. Once you profile your code, you'll be able to see which parts are slow and optimize accordingly. Java is a little bit trickier because if you want to do manual memory management, you have to jump through some hoops, so it doesn't enable itself to performance optimizations as much, but it can be done and you can do it. Another noteworthy thing that I should mention is towards the end of the series, my code style switched quite tremendously, and that's because I switched as a developer from a pretty strict object-oriented programming paradigm to more of a blended style between functional, object-oriented, and imperative type of programming paradigms. So I apologize for that. The engine is not very consistent, and that is something else I would encourage you to do. Make sure it's consistent in the paradigm you're using. Make sure it's consistent in the way you access different components and everything. We've also talked about distribution, and if you want more information on how to package a jar, I'll try and link any useful links of that nature. I feel like I've mentioned a lot of the core concepts that you need to create a reusable game engine. If you guys aren't happy with anything, please let me know in the comments, but I am going to be done with the series for now. I will say though that I am preparing for a Minecraft tutorial series. I'm going to take a vastly different approach to how I teach that series. It's not going to be follow along code, but it's more going to be conceptual with some supporting code snippets when needed. And I really hope you guys stick with me for that. I hope you guys have learned something from this series, and I hope that you are able to take away anything that you have learned and create some cool games. If you have any cool games to show off, post them in our Discord. We have a Discord link in the description, and if you post your game there, I would want to play it and check it out, and I know a lot of other members of that Discord would love to play your games as well. Share it. It's fun to experience other people's creations, and it's fun to share your creation with other people, so don't hesitate to reach out. If you have any other questions, join the Discord. Ask the questions there, because we have a lot of very smart people who are more than willing to help with all sorts of different needs. So join the Discord, and we will do our best to make sure that you have everything you need to succeed at Game Engines. We've gotten to a pretty good point. Ray tracing, or ray casting, not ray tracing, is working. We can see which block we're hitting, and we can get exactly the point that we hit on that block, which is awesome. We can run around the world. We've got a little command line thing pop up. We can pop up our draw calls and everything. This is like really starting to look like Minecraft, and we're getting close. Once again, thanks for going along with me for this 1.5 year, almost 2 year long series, and I really hope you enjoyed it, and I hope you'll join me for the next series. Keep an eye out. The first episode should be airing towards the mid to end of November at the latest. So I hope you guys will join me for that series as well. And it's been fun doing this series. I'll see you guys next time. Thanks.